In this lecture, I am going to throw some light on spherical coordinates and some of the operators involving del, that is uh, like gradients, curl and divergence. So, initially let us discuss about spherical coordinate system. In spherical coordinate system, any point P can be represented as r, theta and phi. Now, if you visualize how a spherical coordinate is formed, then we can easily come to a conclusion what is r, what is theta, what is phi and their meaning. Now, how to visualize a sphere? Now, basically, how can a sphere be formed? So, take a radius and the radius so taken, you rotate it in the vertical plane. So, why it is called vertical plane? Because this is in this plane it is being rotated. So, rotate this radius vector in the vertical plane by 180 degrees. So, this is theta, this is 0 degrees, that means the angle made with respect to the reference vertical is 0 and here it is 180. So, the tip of this radius vector is going to describe us a semicircle. The semicircle so formed, you are going to rotate it in the horizontal plane by 360 degrees. So, the semicircle, if it is rotated in horizontal plane, will form a sphere. So, the best example I can give for a sphere is simply an orange or a football. So, if you can visualize an orange or a football, you can easily come to a conclusion of how it is been formed. So, any point P on spherical coordinates is represented as r, theta, phi. Now, let me explain you what is r. Now, if you take r, simply it is the distance of the point P from the origin. So, if I consider a point P here, r, theta and phi. So, the length of the radius vector is your r. And what is theta? So, this vertical angle is theta. So, in this visualization, this vertical angle is theta. That means the angle made with respect to the reference vertical, with reference vertical and the radius vector. So, this angle would be your theta. And make this point fall onto the ground or floor. So, that is, let me name it as some P dash. So, what is P dash? P dash is the vertical projection of P onto the ground. So, join now O, the origin, with P dash. So, this is your, this portion OP dash is the horizontal projection of radius vector onto the horizontal, I mean it is a vertical projection of OP onto the horizontal plane. So, now take this angle, which is the angle made by the reference horizontal. So, let me name this x-axis as reference horizontal. Okay. So, with respect to the reference horizontal, whatever is the angle made by our OP dash, that angle we are going to call it as phi. So, if you observe, theta is directly taken with respect to the with angle between the radius vector and the reference vertical, but coming to the angle phi, it should be made fall onto the horizontal plane, and on the horizontal plane only we are going to check, we are going to determine the angle between the reference horizontal and the projection. So, always theta is measured in vertical plane and phi is measured in horizontal plane. This point is very, very important because this point carries a weight in the forthcoming discussion. Now, let us come to increments now. So, if I talk about increments, let me say a point P, r, theta, phi is moved to P dash of r plus dr, theta plus d theta and phi plus d phi. So, how to visualize these increments in the 3-dimensional plane? Okay. So, that means if I am talking about increments in r, so the small length I can call it as dr. Okay. Now, let me take increment in theta. So, this is, now let me show you clearly. So up to here it is r, and from here it is dr. So this is dr, and now let me show you the angle. So if up to this point it is theta, and this distance or this angle is d theta. Next, coming to d phi. So up to this angle it is phi, and let me take small angle increment here. Okay, so and let me name this as, let me join this. So this angle is d phi. So this angle is d phi. So now let me project it upwards. Okay, so this is the incremental cone which is formed on the surface of the sphere. So it will be looking like this. So simply this r and this theta and this phi. Okay, so this is your increment in phi direction. So this is the increment in phi direction, and of course you can call it as simply d phi. This is the increment in theta direction. So it is d theta, and this is I can call it as dr. So I can call this as dr. So in this way we can visualize the increments in the three directions r, theta and phi. Now let us calculate the increment length due to this change. So let us start with delta r. So what is delta r? Delta r is the increment in length in r direction. So when the point P, r theta phi is moved to P dash of r plus dr, theta plus d theta and phi plus d phi. Next, if we observe the increment in theta direction, now where is theta here? This is the increment in theta. So this angle is the increment in theta. So if this is d theta, the corresponding increment in length is this length. So if you observe this length, it is an arc, and it is making an angle of d theta at the center. Okay, it's making an angle of d theta at the center, and this is length is r. So what would be this length actually? Now that length obviously is calculated with the formula S is equals to r theta, where r is the sector length, S is the sector length, r is the radius, and theta is the angle subtended by the sector at the center. So since the sector angle subtended is d theta, I can easily write delta theta, which is the change in length in theta direction, as simply r into d theta. Okay. Next, on similar lines, coming to next delta phi. So what is delta phi? Delta phi is increment in the phi direction due to a change in angle of d phi. So now let us start with this analysis. Now this angle is phi and this is d phi. So if you observe the condition in the ground, so this is the increment delta phi, that is the increment in phi direction due to an angle of d phi at the center, an incremental angle of d phi at the center. But where is this lying actually? This is lying on the floor. So I want this distance on the floor. So if this distance is the radius on the floor, then I can directly apply this formula and I can get the incremental length in phi direction. But this distance is not on the floor. So what would be this distance on the floor? Now for that, visualize this figure. So if you observe this figure once again, so if this angle is theta, and this angle obviously would be 90 minus theta. So from this figure, this is r, this is the floor. So this r, when it is falling onto the floor, so it is this distance we want for calculating the incremental length in phi direction. So for this to be calculated, first I would like to consider this triangle. So if I consider this triangle, what do I get? So this is r and this is the floor. Okay, this is the floor. I mean, which is the distance I want. So let me call this distance as some x, and this is the perpendicular. Okay, so the angle between this horizontal and perpendicular is exactly 90 degrees. So if you visualize this clearly, so it is like this. So this is x and this is r and this is the projection. Okay, so x is what now? X is the horizontal projection. So which I want. Now what is this angle? Obviously, now we know that the angle made by the radius vector with respect to the vertical is theta. So can I say it as 90 minus theta? So this would be 90 minus theta. Now from this triangle I can say that x by r is cos of 90 minus theta, or of course sin theta. So from this x I can write it as r into sin theta. So this is very important relation, because I want the distance, I want the projection x onto the horizontal plane for determining the incremental length in phi direction. So it is not directly the radius take for delta phi determination. Radius onto the horizontal plane is given by r sin theta. So obviously delta phi would be this distance into the angle. So that is r sin theta into the angle is d phi. So obviously delta phi is d r sin theta into d phi. Now we can conclude that delta v is obviously equals to the product of the increments in the three directions, delta r into delta theta into delta phi, and finally you can, from this I can write as r square sin theta dr d theta and d phi. Okay, so this has got a lot of meaning, because from this formula only I can get the value of v, the volume of the sphere, as 4 by 3 pi r cube. So let us examine how we got v equal to 4 by 3 into pi r cube. Now if you consider a sphere, so what is the volume? It is simply triple integral dv. And what is dv from this formula? So it is simply r square sin theta into dr d theta d phi. And what are the limits of r? R varies from 0 to capital R, which is the radius. Theta is from 0 to pi. Theta is from 0 to pi. And phi varies from 0 to 2 pi. So if I substitute, what is r square dr? It is simply r cube by 3 from 0 to capital R. And what is sin theta d theta? It is simply minus cos theta from 0 to pi. And this is phi from 0 to 2 pi. So the first one is r cube by 3 into, what is minus cos pi? Minus cos pi is 1. And minus of, second minus would be the limit. So minus of minus cos 0, that is 1 minus of minus 1, which takes a value of 2. So r cube by 3 into 2 into 2 pi. So it is simply 4 by 3 into pi into r cube. So in this way we are going to determine the incremental volume dV in case of a spherical coordinate. So anybody if asks you what is the incremental volume in spherical coordinate system, so you should be in a position to say within no time that it is r square sin theta dr d theta into d phi, and the derivation part of it is shown here. The conversion formulae from spherical to Cartesian, that is we know spherical and we should determine the corresponding Cartesian coordinates. So that is x, y, z are to be determined and r, theta, phi are given for you. So x is r cos sin theta cos phi, and y is r sin theta sin phi, and z is r cos theta. Now how to remember this is simply I remember the y as r s s and this r s c. Okay. Now what does it imply? So first is you will be getting theta first of the two angles. So which is the first angle? Theta will be the first angle. So obviously r into s stands for sine, and what is the first angle? It is theta. So r into sine theta into obviously cos phi. So that's the first x value. Similarly, what is RSS? It is r into first angle is theta. So first s is the subscript for us. So r into sine theta into sin phi, so that is y. And what obviously once we determine these two, so which is not there in theta, sin theta is there in both the cases in x and y. So cos theta is not there. So obviously r into cos theta would be the value of z. So in this way we can determine, we can remember or memorize the formulae x, y, z in terms of r, theta and phi. Now let me explain you the conversion formulae from Cartesian to spherical. That is, we know Cartesian coordinates x, y, z, and we need to determine the spherical coordinates r, theta and phi in terms of x, y and z. So what is r? If you observe this formula, three formulae, then easily you can get these three formulae also. So r is under root of x square plus y square plus z square. So if you substitute in this formula these three relations, you are going to get it as r only back. Okay, next, similarly, what is theta? So if you take squares of this and add and take a root for it, it will be simply r into sine theta if you observe. Why? Because it is cos square theta plus sin square theta is anyhow 1. So under root of r square sin square theta into 1 is r sin theta. So in the numerator it is sin theta, r sin theta, and in the denominator it is r cos theta. So it is obviously tan theta. So what is tan theta? Tan theta is under root of x square plus y square by z. So obviously theta, so what am I saying is under root of x square plus y square by z would be simply r into sin theta by cos theta, and it reduces to r into tan theta. Okay, so r also gets cancelled, so you are remaining with tan theta. So from this, what is theta? Obviously tan inverse of under root of x square plus y square by z. Okay, next coming to phi. So obviously from this formula, I can easily say that from this formula, take y by x. So if you take y by x, you will be getting sin phi by cos phi, which is tan phi. So tan phi is y by x, or phi, from that phi is equals to tan inverse phi by x, which is this formula for us. Okay, so tan inverse y by x is the formula for phi in terms of the Cartesian coordinates. So now let us move on to the next concept, which is Coulomb's law. Okay. Before going to Coulomb's law, let me explain what is meant by electric field. Now, what is charge basically? The effect produced by 6.23 into 10 to the power of 18 number of electrons is nothing but 1 coulomb. So, how to make 1 coulomb of charge? Just muster or collect how many number of electrons? 6.23 into 10 to the power of 18 electrons, and this much electrons make 1 coulomb of charge. Okay, so now let me consider an area. Okay, an area in space. Okay, in a 2-dimensional space, for example on the board only like this. Okay, and in that, let me say a charge of q coulombs is located. Okay, now the vicinity around this, the region or the area around this charge where its presence can be felt, means, for example, if I am taking an area here, so in this circle or in this region only its presence can be felt. So if I talk about any points which are not falling in this region or circle, then what can I say? They are not in the electric field. So how to define electric field? The region around a charge up to which its presence can be felt can be called as the electric field. Okay, now consider an electric field like this, containing, let me say, 2 charges. One is of q1 coulomb and one is of q2 coulomb. Okay, and let me say that the separation or the distance between them is d, small d. Okay, so small d is the separation between them. Okay, and Coulomb did some experiments and he came to a conclusion that the force of attraction or repulsion is proportional to their product of charges. So it is simply Q1 into Q2. So what is the force proportional to? It is proportional to their product, and it is inversely proportional to the square of the distance between them. So that is inversely proportional to d square. So if I wanted to merge these two equations, I can write the same equation as the same proportionality as F is proportional to Q1 into Q2 by d square. Okay, Q1 into Q2 by d square. And if I want to remove this proportionality, I need to introduce a proportionality constant. And of course, since force is a vector quantity, I can say that F is equal to, that means the proportionality is taken away and instead of it we are placing an equal to. So when equal to is introduced, we need to introduce a proportionality constant. So that is 1 by 4 pi epsilon naught into Q1 Q2 by d square into A12 cap. Now what is this A12 cap suddenly? A12 cap represents the unit vector along points 1 and 2. That means we are going to join these 2 points 1 and 2. So let me name this point as some P1 and let me name this point as some P2. Okay. So determine the position vector of the line joining P1 and P2. That is, we are going to get a formula x2 minus x1 into I bar plus y2 minus y1 into j bar plus z2 minus z1 into k bar divided by its magnitude, which is under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So that unit vector is to be determined for determining A12 cap. So simply after determining A12 cap, which gives the direction of the force, next substitute in this formula. And what is 1 by 4 pi pi epsilon naught, it's a constant, and its value is given by 9 into 10 to the power of 9. And from this, I can get the value of epsilon naught as 1 by 36 pi into 10 to the power of 9, and we will be getting this value as 8.856 into 10 to the power of minus 12 farad per meter. Now, what is epsilon naught called? Epsilon naught is called as the permittivity of free space, or I can also write this as epsilon is the electric constant of a material, and that is equals to epsilon r times epsilon naught. So, what is this epsilon r here? Epsilon r is the relative permittivity of that particular medium which we are concerned. So, if generally for free space, epsilon naught value is given by 8.856 into 10 to the power of minus 12 farad per meter, which is electric field intensity vector, which is represented as E bar. Now, let us consider an electric field like this containing two charges Q and Q, which are identical. So, if both the charges are equal, we call them as identical charges. So, consider two identical charges Q and Q coulombs separated by the same distance D. Now, let me introduce a test charge Qt here. Okay, so between these two, some force of attraction or repulsion might be there depending on their polarity. Okay, so the force between them per unit charge, that means if I am introducing a charge Qt, so how to define E bar? Simply it is it is simply force per unit charge. So F by Q, strictly speaking, it is Qt. So in some cases, in the case if I take the same, all the three charges are same, so it will be simply F by Q. Now, due to the identical charges, what is the force formula by Coulomb's law? It is 1 by 4 pi epsilon naught into Q square by 4 pi epsilon naught D square into 1 by Q. So it gives a formula effectively as, of course, into A12 cap. So it is Q by 4 pi epsilon naught into D square into A12 cap. So this is the basic formula for an electric field intensity due to a point charge Q. Okay, so of course in the next classes we are going to determine the electric field intensity. We are going to derive an expression for electric field intensity due to infinite line charge and infinite sheet charge. Okay, now let us work out some numericals based on these concepts. In page number 125 of Sadiku 4th edition, let us work out one problem on page number 125 at, the problem number is 3.4. Okay, now he says that two point charges Q1 and Q2 are located at, so he says that Q1 is located at 4, 0 and minus 3, and Q2 is located at 2, 0, 1. Okay, and he says that Q2 is it is 4 nanocoulomb, and he is asking us to determine Q1 such that the E at so and so 0.5, 0, 6 has no x component, and he also says that the force on a test charge at 5, 0, 6 has no, this is z component actually, and this is x component. Okay, and so whenever there are 3 to 4 points given in the problem, for avoiding confusion, always take it as a electric field like this. Okay, so just draw a circle and dump all the points which are given in the question. So I am having Q1 at 40 minus 3, Q2 at 201, and I am interested in finding out E bar at the point 506. Okay, so now let me name these points as some A and B. Okay, now the electric field intensity due to a point charge, the general formula is given by E bar is equals to Q by 4 pi epsilon naught into D square into A12 cap. So this is the general formula for E bar when point is given, point charge is given. Okay, so here at point P there would be two components of electric field intensity. One component is due to the charge at A, which is Q1, and one component is due to charge at B, which is Q2. Okay, so now let us write the total equation for the electric field intensity. So if I write the total equation for electric field intensity, I will be getting it as E bar is equals to, due to Q1, what is it? Q1 is given to be, Q1 we need to determine. So let me name that Q1 as some same Q only, or Q1. So Q1 by 4 pi epsilon naught into, now what is the distance between these 2 points? Now P is 506 and A is 40 minus 3. So if you observe this distance, 5 minus of 0 is 1. 5 minus of 4 is 1, 0 and 0 is 0, 6 minus of minus 3 is 9. So, is it not under root of 1 square plus 9 square, which is 82. Okay, and what is the unit vector now? So, coming to unit vector, how to determine unit vector I told? Second point minus first point. So, 5 minus of 4 is I, or simply AX cap, and 0 minus 0 is 0 only, 6 minus of minus 3 is plus 9 AZ cap divided by 82. Of course, this is 82 and this is 82 whole square actually. Okay, because it is d square. And what about the second component actually? The second component of E would be what? It is same only, but the only thing is instead of Q1 you will be putting it as 4 nanocoulomb. So that is 4 into 10 to the power of minus 9 divided by 4 pi epsilon naught into, coming to d square. What is the distance between B and P? 5 minus 2 is 3, 0, 0 anyhow, 6 minus of 1 is 5. So under root of 2 square, under root of 3 square plus 5 square. So 3 square plus 5 square under root is how much? Root 34. So root of 34 whole square into, coming to the unit vector, same process. It is 3 AX cap plus, how much is the AY cap? 5 AZ cap divided by under root of 34. Okay. Now let us simplify this. So now he says that we has got no Z component. So what is the Z component now? So Z component of E. Now let us determine Z component of E. So Z component of E would be, now Q1 is not known for us. Q1 into 9 into 10 to the power of 9. From where I got this 9 into 10 to the power of 9 actually? It is 1 by 4 pi epsilon naught. So, and coming to the Z component, it is 9 by root 82 into root 82 whole square. So it is 9 by 82 root 82. 9 by 82 root 82. Next, plus, what about here? Here it is 4 into 10 to the power of 9, of course with a minus, into 9 into 10 to the power of 9, because it is 1 by epsilon naught, 4 by epsilon naught, and into, now what is the Z component here? 5 by root 34 into 1 by 34. So it is by 5, it is simply into 5 will be there here in the numerator, into 5. From where I got this 5? From AZ coefficient. So that is 34 root 34, and that should be equals to 0. So this is what is the meaning of Z component equal to 0. Now let us determine some, let us cancel some of them. So I think 9 and 10 power 9 can be cancelled throughout. 9 and 10 power 9 can be cancelled throughout. So we are having what? 9q by 82 root 82 plus 4 5 is 20. So 20 into 10 to the power of minus 9 divided by 34 root 34 is equals to 0. And from this, can I write 9q by 82 root 82 is minus 20 into 10 to the power 9 with a minus into, by 34 root 34. From this, simply q is equals to minus 20 into 10 to the power of minus 9 by 9 into 82 root 82 divided by 34 root 34. Okay, of course with the minus sign. So from this, q, if we calculate based on this, I got minus 8.32 nanocoulomb, which is the required answer for us. And if you can check the answers at the back of the book, you can find this answer as Q, of course strictly speaking it is Q1. So Q1 is equals to minus 8.32 nanocoulomb. Now next, on a similar lines, let us determine the charge Q to Q1 based on the second condition, which is force at 506 will be having no X component. Okay, so the basic formula for force by Coulomb's law is simply F is equals to Q Q1 into Q2 by 4 pi epsilon naught E square into A12 cap. Now let us apply the same formula for the two charges which are given in the given problem. So if I apply the same formula, what is first force actually? I mean, here we need to take a test charge at P. So if I take test charge at P, so the force between the test charge at P and Q1 is simply Q1 Q divided by 4 pi epsilon naught into the same one. So we will be getting it as root of 82 whole square, which is d square, into of course ax cap plus 9 az cap divided by root 82. Okay. Next plus Q1, I mean Q1 will be Q2 will be known for us. Q2 value is simply given as 4 nanocoulomb. So Q into 4 into 10 power minus 9 divided by 4 pi epsilon naught into here what is the distance? 34. Of course root 34 whole square is 34 into simply 3ax cap plus 5 az cap divided by under root of 34. So this is the total force acting upon the point charge located at P506. Now he says that the force at so and so point has got no x component. So what is the total x component now? Now let us determine the total x component. So what is the total x component? So let me segregate the total x component. So total x component is what? It is Q1 by 4 pi epsilon naught into 82 into, yeah, this is the x component here. The multiplicand for x component is 1 by root 82. 1 by root 82 plus 9, I mean Q into 4 into 10 power minus 9 by 34 into 4 pi epsilon naught into, this is the 3 by root 34 is our multiplication for x component, and that should be equals to 0. Okay, so I can throw out cancel away q, and I can also as well cancel away 4 pi epsilon naught. So what are we remaining with now? Q1 by 82 root 82 is equals to minus 3 into 4 is 12. So minus 12 into 10 power minus 9 by 34 root 34. So if I calculate this by solving this calculation from calculator, I will be getting it as minus 12 into 10 to the power of minus 9 into 82 root 82 divided by 34 root 34, and the final answer for this would be minus 44.94 nanocoulomb, which you can check with the answers given at the end of the book. Okay, so in this way we can determine the electric field intensity and the force between any two charges. Now in the next class we are going to discuss about the electric field intensity due to infinite sheet charge and infinite line charge. So if you find this video to be interesting, please subscribe my channel TV Education.